Hey everyone, have you ever tried to learn how to code but got stuck? In my new Python programming class, we're going to break that loop. This course is primarily focused on people who are complete beginners, so don't worry if you don't have any background. This course is different than other courses because we're going to teach you to think like a programmer and solve problems like a robot. So let's get started. Hi everyone. So the last video we talked about exception handling, which seemed a little bit like a non sequitur, but allowed us to kind of talk about how to make this faster and a little bit more efficient. We have this line of code here now that we can take in a message and we can encrypt that message. Okay, so now what we're going to talk about is going in the opposite direction, is decrypting a message. So we want to be able to go from this back to the original values that we had, right? So actually the way that we can do this is in a very similar way that we had done our encrypt letter function. So let's define decrypt letter. To keep it consistent, we're going to take in a letter and we're going to say right shift, same thing, it's equal to 23. It's going to be our default value. Same thing we're going to do here. Let's just copy this. Well, we're going to type it in just so we can be clear. So translate letter to number, letter. So decrypted number is equal to decrypt number. So now we're just going to take in that same number and decrypt it instead of encrypting it, right? So that's all we have to do is instead of using this function, we already wrote this function out, but instead of going from, in our original case, we went from A back to X, it's going to go in the opposite direction. So it's going to go from X up to A. So that's what we're going to do. We're going to decrypt that number, go back in the opposite direction. And then we're just going to say that decrypted letter is equal to translate. We're going to translate this number back to a letter, right? So we go decrypted number, and then we're going to return decrypted letter. Okay. So same idea. We're going to take in a letter, except this time it's going to be this jumbled letter. And the only thing that changed is that we're now using this decrypt number function instead of the encrypt number function. And then we're going to return it back. So let's try doing the same exact thing and decrypting this message. So we have this encrypted message, right? So we're going to say decrypted message here. We're going to call this decrypted message. And we're going to take in the letters of our encrypted message, right? So to remind you, this encrypted message is this EF, that was an old value, but this is EFQEBOB. Looks like gibberish, right? So we're going to take a character in. We're going to say, okay, decrypted. So this is going to just involve a lot of rewriting the same thing, but it's the same idea. We're going to say decrypted letter is equal to decrypt letter character 23. And do the same thing. If there's a key error, if we don't know how to decrypt it, we're going to set it equal to a space. Now this isn't going to happen in our case because our decrypted message won't have any punctuation in it, but it will have spaces. So actually it is useful to have. And then we're going to say decrypted message is equal to plus or equal to decrypted letter and then decrypted message. So it looks like I spelled something wrong there. Translate as it was in this guy. Translate letter to number. It's right here. So that was a name error. You see, I was talking about different types of errors before, and that's one type. And there we go. So very simply, we were able to just reverse the process. We use our decrypt letter, and instead of using the encrypt number, use decrypt number, go between numbers and letters. And then we go through that encrypted message, this kind of jumbled up message, and then do that decrypt letter function on each character and add it on to the end of the list for the decrypted message and take a look at it. And there we go. That was the original message that we sent. So you can see it's kind of inverted, right? I sent you the message EFQ Bob LRO MX PPTLOA FP MX PPTLOA, which seems like complete gibberish to anyone else. But because you know that I'm doing this specific operation, you can decrypt that message and come back with the original message. Hi there, our password is password. So that's the entire process, right? Nobody else would be able to read that message except you because you know the exact number that I used here for this right shift, really, right? And as long as you know that, you'll be able to decrypt my message. So to give a little bit of an illustration as well as to explain why we even went through the whole trouble of being able to do this easily is if I made this 5, this message is different, right? This encrypted message is now MN, it's still gibberish, but not the same gibberish, right? If I try to use this same decryption, it's not going to work, right? Because that's not the correct number, the correct key, actually, it's called. But if I use 5 here, again, I'll be able to translate back from this encrypted message back to the decrypted message. So that's the idea. Is now, pretty simply and pretty straightforwardly, I was able to create this decrypt letter using the same logic I had for my encrypt letter, right? And then decrypt the original message. So that's pretty much everything we have for this idea of a Caesar cipher. Now, the next thing we're going to do before we close things up is just clean things up a little bit for ourselves. So I'm going to make 2 functions. I'm going to say, so we've been doing this with a particular type of message, and we've been having to pass those in particular points. And that works for now, but what if we want to use a different message? It'd be a little bit of a time-consuming effort. So I'm going to define 2 functions. I'm going to say encrypt message, and then I'm going to literally, again, just take this same code here. And again, you're going to have to do some things with the indenting, right? The indenting has to make sense, right? So unless there's a loop or something with a colon, everything's got to be in a straight line. And then the indent, you move it over a little bit. But okay, so now we have this. This is the same exact code that we were using, but instead of printing out the encrypted message, we're going to want to just return encrypted message. Okay? And we're going to do the same thing with decrypt message. So we're going to say decrypt message, and then we're going to do the same exact thing. So I'm going to paste this guy in. I have to change a little bit. I'm just going to change this to message instead of encrypted message. And then, just return decrypted message. Okay, cool. So really the purpose of this is so I'm going to put in another message. This is another message just to make things a little easier for us. This will jumble up this message for us. And now if I have, jumbled, and then if I decrypt this message, decrypt message jumbled, I'm going to get the original message back. So great. I now have my 2 functions that will be able to handle this.